So you've probably had this happen, right? You ask an AI a question, and it gives you an answer that sounds super confident, but it's just completely wrong. Well, today, we're diving into the fix for that. It's called Retrieval Augmented Generation, or RAG for short. And it's this really elegant idea that's teaching AI to stop making stuff up and actually start doing its homework.
This quote from Ars Technica really just nails it. It's all about blending what the AI already knows with a real-time lookup, kind of like a web search. The goal? To help these models stick to the facts. The library card analogy is perfect. Instead of just guessing based on what it remembers, the AI can now actually go look things up, check its sources, and make sure its answers are grounded in reality. And seriously, we've all seen this, haven't we? You ask a chatbot something, and it spits back this answer with so much conviction, but it's just pure fiction. It's a massive, massive problem in the AI world, and it actually has a name. Okay, so before we can really appreciate why RAG is such a game changer, we first have to talk about the problem it was designed to fix, and that is the dreaded AI hallucination.
So, what exactly is an AI hallucination? Well, it's when a model generates information that sounds super confident but is factually incorrect or just nonsensical. The crazy part is, it's not really a bug in the traditional sense. It's more of a fundamental limitation. See, the AI isn't trying to lie to you, it's just a prediction machine, trying to figure out the most probable next word in a sentence. And sometimes that path of probability leads it to invent facts, make up sources, or describe events that just never ever happened.
And here's the root of the problem. A standard large language model, or LLM, is essentially stuck in time. You can think of its knowledge as being completely sealed off from the outside world. It's frozen on the day its training data was finalized. That means no access to breaking news, no idea about your company's internal documents, and zero knowledge of anything that's happened since it was created. And believe me, the stakes for getting this wrong, they are incredibly high. Just look at what happened when Google first demoed its Bard AI. It confidently gave a wrong answer about the James Webb Space Telescope, a single mistake, and that one hallucination contributed to a staggering $100 billion drop in the company's stock value. Yeah, this isn't just some quirky little bug. It's a serious, serious business risk. All right, so if that's the $100 billion problem, what's the solution? Well, this is where RAG enters the picture. So, what is RAG? Simply put, Retrieval Augmented Generation is a technique that gives an AI model the power to look stuff up from external sources before it even tries to answer you. It retrieves relevant, up-to-date information first. This simple step is what grounds the AI's response in actual facts, and it dramatically reduces the odds of it making things up. I think the best way to wrap your head around this is the open book exam analogy. A standard LLM, it's taking a closed book test. It can only rely on what it memorized during training. But a RAG-powered LLM, it gets to take an open book exam. Before answering, it can look up the facts in a textbook, which is basically your own trusted data. This means it's not just guessing, it's accessing current, verified information. Okay, so this open book exam concept sounds great, right? But how does it actually work? Let's pop the hood and take a look. The whole thing really boils down to two key phases. First, there's an offline preparation phase. Think of this as building and organizing the library. And then there's the real-time query phase, which is what happens every single time a user asks a question. That's, actually using the library. So phase one is all about that prep work, the indexing. First, you load your data from wherever it lives. Documents, websites, databases, you name it. Then, you can't just throw giant documents in there. You have to split them into smaller, more manageable chunks. Finally, and this is the really cool part, you convert those chunks into a numerical format. We call them embeddings, and store them in a special kind of searchable database. This basically creates a super smart index for your entire library of knowledge. Okay, now for phase two, the real-time magic. You, the user, ask a question. Instantly, the RAG system dives into that database and retrieves the most relevant chunks of information. Then, it bundles your original question together with those retrieved facts and sends the whole package to the LLM. It's essentially saying, hey, here's the question, and here are the specific facts you need to answer it. Now, give me an answer based only on this context. Now, RAG sounds pretty amazing, I know, but it's not a magic wand that solves every problem. So let's get real and talk about the pros and cons. When you look at it from a high level, the trade-off is pretty straightforward. On one hand, you get a huge boost in factual accuracy and access to real-time information. The flip side, well, you're adding more complexity to your system, it can be a bit slower, and this is a big one, the quality of your answers is completely dependent on the quality of the data you feed it.
But man, the upsides are significant. First, there's improved transparency. A RAG system can actually cite its sources, which is a huge deal for building trust. It also lets you create domain-specific experts on the fly. You want an AI that's an expert in law or medicine? Just feed it the right legal texts or medical journals. And it's way more cost-effective. Updating your knowledge base is so much cheaper than retraining an entire billion-parameter model every time something new comes out.
Okay, but let's not gloss over the downsides. There's definitely a maintenance overhead. That external library doesn't update itself, it needs to be constantly curated. You're also juggling more infrastructure, the retriever, the generator, the database, which can add cost and complexity. And maybe the biggest risk is retrieval bias. If the system pulls irrelevant or biased information to answer a question, the final answer is going to be flawed. It's the classic garbage in, garbage out principle, plain and simple.
And this points to a really subtle but critical danger, misinterpreting context. Here's a real-world example. An AI was asked if Obama was the first Muslim president. The RAG system did its job and retrieved a relevant source, a book with the title Barack Hussein Obama, America's First Muslim President. The problem? The AI completely missed the question mark at the end. It didn't understand the rhetorical nature of the title, took it as a statement of fact, and generated a confidently incorrect answer. It shows that even with the right facts, context is everything.
So, when you weigh the good against the bad, what's the big takeaway? Honestly, it's pretty clear. RAG is a technology that is fundamentally changing the game. Here's the big picture. RAG is making AI more factual and a whole lot more trustworthy. It's the bridge that connects these incredibly powerful but static models to the dynamic, live world of information. And that is what's finally making it possible to use AI safely in high-stakes fields like finance, healthcare, and law, where getting it right isn't just a feature, it's absolutely everything. And at the end of the day, as promising as RAG is, it's not a silver bullet. This quote from Digital Define puts it perfectly. It's a promising architecture for sure, but it's one that has to be carefully fine-tuned, monitored, and maintained to really live up to its potential.
And that really leaves us with a final, pretty profound question to think about. RAG gives AI access to all of our knowledge. It's like handing over the keys to the library. But who curates that library? Who's responsible for making sure the books on the shelves are accurate, unbiased, and up to date? That responsibility falls back on us. The AI is only as good as the information we give it.